Welcome back. We have these questions, limit n tends to infinity, we have n square and we have integral over here, okay. Now when n tends to infinity, this n square become what? This tends to infinity, okay. How about this term? When n tends to infinity, this 1 by n, okay, this also become what? 0, okay. Meaning when limit of n tends to infinity, 1 by n, this become when n keep on increasing. For example, 1 by 2, 1 by 100, 1 by 1000. Okay, so this become, this tends to what? This tends to 0. Okay, so therefore this become what? This become 0. Okay, therefore integral of anything over here, if upper limit is same as, then lower limit, meaning we have a to a f of x dx, this integral becomes 0. Okay, so now this limit is of the form here, infinity into 0 form. Okay, it is of the form this. Now if I want to apply LHospital rule, what should I have? I have to have either 0 by 0 or plus minus infinity by plus minus infinity. Okay, so either it should be either this way, or it should be either 0 by 0 form or plus minus infinity upon plus minus infinity. Okay, in order to make this, what I can do is I can do this way, limit of n tends to infinity, this n, this I can bring up here 1 upon 1 by n x raised to 2018 x plus 1 upon this, I can write 1 upon n square. Now it is of the form, this become what? It is of the form 0 upon 0. Okay, so this is 0. Okay, 0 to 1 by n. So this become 0 when n tends to infinity. When n tends to infinity, this denominator become a 0. It is of the form 0 by 0. Now we can apply LHospital rule. Okay, now differentiation of this with respect to n is very easy over here, but how about this numerator? Okay, so numerator is what? Let's see how to differentiate this. What is this? D by dn of integral 0 to 1 by n x raised to 2018 x 2018 x plus 1 into, here we have dx. Here also we have dx. So now what I'll do is I will use fundamental theorem of calculus. So by fundamental theorem of calculus. Okay, so what we'll have here, instead of x, what I have to write? Instead of x, I have to write 1 by n. Okay, so this is same as x is what? 1 by n raised to 2018. Instead of x, I have to write what? N. Okay, plus 1. Okay, into, okay, so into d by dn of this. Okay, d by dn of 1 by n is equals to 1 by n 2018 n plus 1. This is what? This same as minus 1. Okay, so it's same as 1 by n square. Okay, minus 1 by n square is differentiation of this is this. Okay, for fundamental theorem of calculus, let's take another example also. Let's take another example. Let's say example. Let's take this example. Okay, for this fundamental theorem of calculus, so that you will have clear idea. Now in this example here we have 3 to x, this we have. Okay, now what we have to do is, instead of t, what we have to write? X. Okay, so here what we have? Cos of cube x raised to 4 upon 4 root of x raised to 5 plus 1 into d by dx of x is what? 1. Let's see over here. Now let's differentiation of this is what? This we have. Okay, let's write down over here. 1 by n raised to 2018 upon n plus 1 into minus 1 by n square. Okay, and differentiation of this is this. Okay, so and then what about this is minus 2 upon n cube. Okay, so this is equals to, limit is what? Limit is n tends to infinity, 1 by n raised to 2018 upon n into, I can say 1 by n. This one I am separating with this, okay. So, and then we have minus 1 by n square upon 2 minus 2 upon n cube, okay. So, this n and n square is n cube, this n cube and this n cube gets cancelled, and this minus and minus gets cancelled. Limit of n tends to infinity, what we have, 1 by n. This 1 by 2 is outside, I can take here, 1 by 2 outside, and 2018 upon n, okay. This n and n square, n cube, this would get cancelled, minus minus gets cancelled, half is over here, okay. So, this is, I can write like this, 2018 is, I can write like this, 1 upon 2018. Limit of n tends to infinity, 1 by n raised to 1 by n. When n tends to infinity, become what? This become 1. Okay. So, this 1 by 2, 1 raised to 2018. Why? Because limit of x raised to x, when x tends to 0 plus, is become 1. Okay. These limits you have to remember, some standard limit. Limit of sine of x upon x, where x tends to 0 also 1, and limit of 1 plus 1 by x raised to x equals to e when x tends to infinity. These are some limits, standard limits you have to remember, okay. So, 1 is to anything is this same as half, okay. This is the required answer.